All right, we're back with some more seminars here with limits, which is part 5 now in our calculus class. So looking at this page 18, we are going to take this out so you can omit doing this one, so put an X through that. I'm not going to test you on that, so leave that out. Okay, so let's move on to a really important topic, the definition of a derivative. Now you guys know how to find derivatives through those quick methods that I showed you in the first part of this course. Now we're going to look at how limits really tie into how we find derivatives and how they connect with each other. So I'm just going to go through this right now. So first of all, let's just make up a function. So I'm going to draw a function here. So let's say we have x and y axis. And let's put a curve in. Okay, so there's our function. All right, now, you guys know that a derivative is the instantaneous slope at a given point. So let's put a given point on this curve. So let's put a dot right there. And we want to find what is the slope of that point right there, x. And remember and recall back that the slope is the tangent line. So that tangent line. Now mathematicians didn't quite know how to do that, trying to find the slope of a tangent line. So Leibniz and Newton were working on this, and they came up with this definition right here. And how it came about was this. So first of all, well, mathematicians knew that if we had a secant line, so if I put a secant line, so let's just make a yellow line. So if I went from that point to say that point and drew a nice line, we could find the slope, because mathematicians knew if you had 2 points, they understood that the slope is y2 take away y1, x2 take away x1. That was known. They knew how to do secant lines. So that yellow line's a secant line. Well, they use this method and tying in limits to figure out the slope, the really accurate way to find the slope at that given point. So we're just going to use this formula right here and write it in notation of our definition. So first of all, we know that if we had another point, I'll just put this guy. So they knew that this distance is h. Okay? It's a horizontal distance going from x to that. So therefore we know this point is x plus h, whatever that distance is, that horizontal distance. Now, we know if those are the 2 x coordinates, the y coordinates, we come this way of that point, is f of x. And this one right here, if we come across, is going to be f of x plus h. Okay? So now we can use this formula because we know what y2, y1, and all those things are. So I'm just going to rewrite this as we have f of x plus h take away f of x, so our y2, y1, all over x2 is going to be this guy here, x plus h take away this x. Okay, so now we are looking more and more like the definition. So if I just simplify this negative x and that take off, and now what we're left with is the definition minus, it's just missing this limit part. All right. Well, that limit part is super, super important, because without that, we couldn't get very accurate. So looking at my drawing up there, so let's take this secant line right here, right? And if I move that closer, so this h is getting closer, closer, closer. So what's really happening is h is getting closer and closer to 0. So I'm making that distance close to 0. We now have the definition. They are the same. So we now are going to find some examples using the definition. Okay, so we have the definition here. I just left out this part so we can put that in. I just didn't type it in. Okay, so here's the given function. So this is what we do. Now the first step, I always say, is wherever there's an x, you're going to put this guy into it. So just remember, where you see that x, or this guy right here, it's going to be x plus h. Okay, so wherever you see an x, just remember, replace it with that. Okay, so let's go through this. So we have 3x plus h plus 1, take away, okay, the function. This is really important. This bracket is super important. It's going to change these guys, right? All over h. Okay, now we're going to tidy up. Rainbow in, rainbow in. So we have 3x plus 3h plus 1 minus 3x minus 1 all over h. Okay, we're going to tidy up a little bit more, because you can see that this can take that off. This can take that off. Now, when you guys are doing definition of derivatives, remember, you are going to get canceling out. If you don't, something went wrong up above. So, what are we left with? Well, we're left with 3h over h. So right in the limit as h is going to 0. Very important. Now we can do one more simplifying. So this h can take that h out. And so the answer is 3. All right. Now let's just check. Let's go back in time. Let's go back to the beginning. And remember that if you had 3x plus 1, all right, and remember, let's just make it y equals, just to make it simple. And I said take the derivative, you would say y prime equals 3. So they equal. Okay, so this is just this whole process to get to there's the definition. Okay, let's try another example. Okay, so where we see that x, guess what it becomes? X plus h squared minus 1. Take away the function, bracket. So that bracket is super important. I leave this part out at the beginning when I'm just simplifying. You can put it in, but make sure you have it down at the end. Okay, let's simplify. Okay, so remember, this means you have 2 of them. That's square, right? So when we FOIL that out, we know we get this minus 1. This changes both of those to minus x squared plus 1 all over h. Okay, let's tidy up. So that takes that off. That takes that off. Okay, so now we're left with 2xh plus h squared all over h. Okay, now this is important, you guys. We want to get rid of this h right here. That h has to go, because if we plug that 0 into there, we have something divided by 0, which is undefined. So we are going to factor here. Factor out h on top. Okay, so let's have a look here. So see there's an h and an h, so take an h out, so we get 2x plus that h all over that bottom h. Now we can get rid of that h, so no h on the bottom, what you want. So now the limit as h goes to 0, and now you're left with 2x plus that. Now we can plug in this guy right here into there, so that we get 2x plus 0, so the answer is 2x. Okay, now let's just double check that. Let's just go back to what we did in the early learning guides. Well, remember, if I gave you f of x equals x squared minus 1, and I said, what's f prime of x? You guys would say 2x. Voila, the same.